This screencast is to demonstrate the method used to determine the rate law using the method of initial rates. So I have some data from 3 different experiments where I vary the amounts of persulfate and amounts of iodide and find the initial rate for those different experiments. I'm going to start by comparing experiments 1 and 2. You'll notice in those 2 experiments that iodide remains constant and the persulfate concentration changes. So those experiments will allow us to determine how the persulfate concentration influences the overall rate of the reaction. So I'm going to put experiment 2's concentration on the top because that way the number is bigger than 1 and the math is easier that way. So I have those concentrations raised to the m power, and I'm going to compare those to the rates. 2.8 times 10 to the minus 5 and 1.4 times 10 to the minus 5. It turns out I have 2 to the m equals 2. That means m must be 1. So the first part of the rate law says rate equals K times persulfate concentration to the m times iodide concentration to the n. And what I have figured out is what m is. I'm going to keep going and figure out what n should be. So in this part, I will compare experiments 2 and 3. I chose those because persulfate in those 2 experiments stays the same. So the only thing that I'm comparing is the iodide concentration. And the iodide concentration is larger in experiment 3 than it is in experiment 2. So again, I make a ratio, use the number n, you could use whatever letter you like, and I'll compare those to the initial rates. And when I do the math, I find that 2 to the n equals 2, so n is also equal to 1. So that tells me my overall rate law. Rate equals K times persulfate to the first power times iodide to the first power. And since those are ones, we don't usually write them. The next thing we have to do is to determine the value of K. Get us a blank screen here. When you determine the value of K, you can plug the numbers in for any of your experiments. You should get the same answer, no matter which one you use. I'm going to pick the top one. Rate 1.4 times 10 to the minus 5 equals K times 0.038 times 0.060. Rearrange to solve for K. And I will multiply those out to get the value for K and the units. Molarity per second over molarity and molarity. So the units will turn out to be per second per molarity. So I multiply the numbers out, and my final answer is 6.14 times 10 to the minus 3. The units are reciprocal molarity, reciprocal seconds.